Hello friends, my name is Archana and welcome to my channel Circuit Globe. Today in this video, I will explain you what is armature reaction in DC machines. After watching this video, you will be able to know what is armature reaction, what is geometrical neutral axis, what is magnetic neutral axis in DC machines, cork screw rule, and the effect of armature reaction on the DC machines. So friends, let's get started. First of all, understand what is armature reaction. The DC generator has three main parts. The first one is the magnetic field system, the second one is the armature conductor, and the third one is the brushes and commutator. Now here what happened, the magnetic field system induces the magnetic flux in the DC generator, and when the current flow through the armature conductor, then armature conductor induces the armature flux. When these two flux interact with each other, then the effect of armature flux on the main field flux is known as the armature reaction. Now, what are the effect of armature reaction on the main field flux? The armature reaction has generally two effects on the main field flux. The first one is that the armature reaction distorted the main field, and the second one is that it demagnetized the main field flux. Okay. Now friends, what will happen if armature reaction distorted the main field? If armature reaction distorted the main field, that means the total voltage that generated in the DC generation, their magnitude will be reduced. So we can say that armature reaction reduces the generated voltage of the DC generator. Now second thing is that in DC generator, the position of brushes and commutator is decided by the magnetic neutral axis. Now, if the armature reaction weaken the main flux, in that case, the position of magnetic neutral axis will be shifted. So, it is quite difficult to know the exact position of the magnetic neutral axis. And if we are placing brush in any other position, then the brush will be get damaged. So, it is very essential to know the position of magnetic neutral axis. But the armature reaction weaken the main flux, and because of which the magnetic neutral position will be shifted. So because of the armature reaction, it is also difficult to know the exact position of the MNE. So guys, these are the adverse effect of armature reaction on the DC generator, and hence it is very essential to reduce their effect on the machines. So friends, before knowing much about the topic, first of all understand what is the geometrical neutral axis and what is the magnetic neutral axis. In case of DC generator or DC motor, any axis which is perpendicular to their stator field axis, that axis is known as the geometrical neutral axis. Here you can see in this image, this is the stator, this is our stator, and this is the field axis. If we draw any line which is perpendicular to the field axis, then that line shows the geometrical neutral axis of the machine. Now, what is magnetic neutral axis? The axis where no EMF induces in the armature conductor, that axis is known as the magnetic neutral axis. And as there is no EMF induces in that line, so we are placing our brushes and commutator in that axis. Here you can see this is the magnetic neutral axis of the DC machine. We are placing our brush and commutator in that axis only because there is no EMF in that axis, so brushes are safe and they are not getting damaged. Okay, so this is the magnetic neutral axis and this is the geometrical neutral axis of the DC machine. So friends, for understanding the armature reaction, consider the three cases. Okay, first of all, consider this is the image of the DC machine. These circles shows the armature conductor, and these are the main magnetic field system. These are the magnetic flux. It is the magnetic neutral axis and the geometrical neutral axis of the system, and these are the brushes. Okay, now consider the three cases. The first case is that when no load is connected to the machine. No load is connected to the machine, that means no current flow through the armature current. No current, that means no flux induces in the armature conductor. So here in that case, only the main field flux is present in the DC generator. Okay, and that flux is symmetrically distributed between the armature conductor. Here you can see this is the polar axis of the magnetic field system. Polar axis means the central line between the north and south pole. So the flux, the main field flux are symmetrically distributed between the conductor. One more thing friends, as you all know that brushes are always placed along the magnetic neutral axis of the system. Here you can see the magnetic neutral axis and the geometrical neutral axis coincide each other. Okay, and that axis is also called the axis of commutation. It is called the axis of commutation because we are placing our brush and commutator in that axis. So it is the another name of magnetic neutral axis. Okay. Now friends, consider the third condition in which the armature conductor carrying current and no current flow through the field's coil. Okay, so you can see here the armature conductor carrying the current. The plus sign shows that current flow inward direction and the dot sign shows that current move out of the conductor. Okay, and no current flow through the field coil. The only flux that present in the DC generator, that flux is because of the armature conductor. Okay, the direction of the armature conductor is given by the Fleming right hand rule. The Fleming right hand rule says, suppose we are spreading our right hand finger like this, so the thumb shows the motion of conductor. The middle finger, the index finger shows the direction of magnetic field that occur in the conductor, and the middle finger of the right hand shows the direction of the current. So in DC machine, the direction of armature conductor is given by the Fleming right hand rule. Okay, and because of the current, the flux induces in the conductor. So the direction of flux is given by the Maxwell corkscrew rule. For Maxwell corkscrew rule, consider this is a conductor. In that conductor, the current is flow from left to right. Okay, and because of the current, the magnetic field induces in across the conductor. Now consider one screw. We are having one screw and we have to rotate that screw from left to right. For moving that screw from left to right, we have to apply some force on that screw. So we are by the help of our hand, we are moving that screw in that direction. Okay. So when we apply force in that direction, screws start moving from left to right. Okay. It is the direction of current and the force that we apply on the conductor on the screw for moving it from left to right, that direction is the direction of the magnetic flux. So by the help of this screw rule, we find the direction of flux in the DC machine. Okay, and Fleming right hand rule is used for knowing the direction of current. Okay, now what happened? We are finding the direction of current and the direction of flux. So suppose under north pole, these are the conductor that line. So these conductor combine their magnetic motive force to the current and try to produces the flux in the downward direction. Okay. Similarly, the conductor that comes under the south pole, they are also including their magnetic motive force, and because of their magnetic motive force, one flux induces and the direction of flux is in the downward direction. So in short, we can say that both of these conductors try to induces the flux in the downward direction of the DC generator. Okay. Now consider the third condition. Suppose that our machine is on load. Guys, when machine is on load, that means the current start flowing from both the main pole and the armature conductor. When current flow from the main pole, that means magnetic flux induces in the machine. And similarly, because of the armature current, the flux start inducing in the downward direction of the conductor. Okay. Now here what happened? The flux induces simultaneously. Means both the magnetic flux and the armature flux. That flux induces simultaneously. When these flux interact with each other, then we get one resultant flux. Okay. And that resultant flux is known as the armature reaction. Because of the interaction of field flux and the armature flux, one resultant flux induces, and that flux is known as the armature reaction. Now, what are the impact of armature reaction on our machine? Guys, when armature reaction occur in the machine, in that case the flux are unevenly distributed among the conductor. Consider that this is the upper pole tip of north pole and this is the lower tip of north pole. Similarly, this is the upper tip of south pole and this is the lower tip of south pole. Now here you can see here the density of flux is quite less as compared to the lower pole tip of the south pole. Here density is high, here the flux density is high and here the flux density is low. Similarly, in the lower portion of the North Pole, the flux density is high, and in the upper portion of the South Pole, the flux density is very less. That means the flux are unevenly distributed amongst the conductor. Okay, because of this uneven distribution of flux, the magnetic neutral axis of the plane may also get shifted. Here you can see this is the magnetic neutral axis of the machine, but because of the distortion that occur in the flux, this axis shifted towards any particular direction. So we can say the armature reaction shifted the magnetic neutral axis. Okay, it also reduces the terminal voltage of the machine. Suppose in case of DC generator, when armature reaction occurs in the machine, the magnitude of that voltage reduces because of the armature reaction. So many effect of armature reactions are there. Okay, what are their harmful effects on a machine? Let's see. Effect of armature reaction on machine. When armature reaction occur on the machine, then what are their effect on the machine? Let's see. Guys, what happened, as I explained you earlier, because of the armature reaction, the uneven distribution of flux occur in the machine. Because of this uneven distribution, the total voltage of the machine may get reduced. Okay, so the effect through which the total flux induces in the machine may get reduced, that effect is known as the demagnetizing effect. So, because of the armature reaction, the demagnetizing effect occurred in the machine. Now second case is that because of the armature reaction, the magnetic neutral axis of the machine may get shifted. Okay, as you see, this is the magnetic neutral axis of the machine. But when armature reaction occur in the machine, their position may get shifted. This magnetic neutral axis turn towards the direction of machine in case of generator, and if we talking about motor, then it's move in the opposite direction of the machine. Now consider the third case. The armature reaction established the flux in the commutation or neutral zone of the machine. As I explained you earlier, in the neutral zone of the machine there are no EMF induces because we are placing our brushes here. Okay, because of the armature reaction, the flux induces in that axis. That means the flux induces in the commutation axis of the machine. That means the brushes may get damaged. So these are the main effect of the armature reaction on the machines. So friend, this is all for today. For getting more detail about the topic, you may refer my official website, which is the circuitglobe.com. Here you can see I explain the topic in detail. So you can also refer this site for studying the topic. Okay. So friends, I hope you like my video. For getting more video like this, don't forget to like, comment, share and subscribe my channel.